Have you been looking for a programming language that has been battle tested over decades, has near sea-level performance, has modern programming language features that most languages wish they had, has an active community, and is still easy to learn and write? Then Lisp might be the language that you've been looking for. Now that may have been quite a lot of promises to make right off the bat, but I think you guys will find that as we go through this, most of these promises are actually met or even exceeded. Now, when I refer to Lisp, I think it's important that I distinguish what exactly I'm talking about because there are a lot of implementations of Lisp, so I think it's important that I give you guys just a surface level understanding of the different implementations that you may want to look at. Now, there are 3 implementations that I figured I would talk about. First one is Scheme, the next one is Common Lisp, and the other one is Clojure. I won't go into too much detail. I plan to make a video in the future that goes a bit more into detail on the differences between each of these, which one you should learn and when, but the process is pretty straightforward. Now, the first implementation I wanted to talk about was Scheme. It's probably the oldest of all of the implementations. It is focused on minimalism, and it has a lot of really interesting goals in mind, such as the use of recursion rather than something like a for loop. And it's a lot of inspiration for the modern functional programming language features that you would see nowadays with things like map. Now, something I should also mention is that Scheme has a lot of different variants. There's a lot of different versions of Scheme. There's Chicken Scheme, there's Chess Scheme or Ches Scheme. Not really too sure how you're supposed to pronounce it. And there's a lot of different implementations of Scheme out there, and this is mostly due to the fact that the actual specification to be a scheme is very broad and very small and simple. So usually people that implement Scheme usually extend it and add a lot of new features, such as things like threads are very common, or foreign function interfaces, so you can interface with C libraries. And so this is kind of what you can expect from a lot of schemes. Probably the most popular scheme out there is Racket, but Racket goes quite a ways beyond the minimalism of Scheme. If you want to take a look at Racket and Scheme in general, I actually have a video on it that I will put up in the card above as well as down in the description. Now, the next implementation on our list is Common Lisp. One of the big things about Common Lisp is that it has a lot more language features than Scheme, and because of that, a lot of its popularity kind of came from that featurefulness. And because of that, a lot of the implementations of Common Lisp usually just implement Common Lisp and then a few extra extensions like threads. And because of that, the actual libraries that are out there usually support multiple implementations. So you aren't exactly tied down to one quite in the same way that Scheme would be, where most of the libraries aren't really compatible with all implementations. While there are a lot of implementations of Common Lisp, Steelbank Lisp, or SBCL, is probably the most common implementation out there. It is very performant. It has near sea-level performance in lots of use cases, so be sure to check it out. It also has some really interesting features for things like type checking when you compile, and a lot of other cool features that I think are pretty standout when compared to other compilers. And for the last implementation that we'll be talking about and referring to is Clojure. Clojure is probably the newest one on the list. It has a lot of modern features built right into the language, although as we go through here, you'll realize that having modern features built in doesn't really make one Lisp better than the other one right out of the gate, because Lisp has a lot of functionality for extending the language. Clojure makes all types basically immutable, so you can't be changing the value of variables as you use it, which some would consider a plus. It also has a lot of features taken from other functional programming languages as well. And it includes a lot of modern programming features like threads right into the language, which is something that you won't see in the other implementations that we talked about. Now, Clojure has basically 2 endorsed implementations. The most popular, or the most well-known one, is Clojure itself, which runs on the JVM and allows interop with Java. It's a pretty interesting language. And then the other one out there is Clojure Script. Clojure Script actually transpiles to JavaScript. So if you guys have wanted to use a language for 2 different interfaces like that, then Clojure has a lot of power there. It allows for extensive scalability since you can use it on the front end and the back end, and you have the performance of the JVM and as well as the entire Java ecosystem available for you. In addition, since Clojure actually has threads built into the language, you will notice that it has a lot of focus on multi-threading and parallel computing. So if that's something that would sell you on a language, then maybe take a look at Clojure over the other 2. Not to say that you can't do that in the other 2, just Clojure has that a lot more focused on in the language. Now let's get into what exactly makes Lisp so good and give you guys a few explanations and examples so that you guys can kind of get a better idea of what I mean by each of those statements I made at the start of the video. Now, the first thing I wanted to talk about is that Lisp is actually very easy to get started with and start learning. If you guys want to start learning, I'd recommend taking a look at Scheme just to start off with, because since Scheme is so small and simple, you can learn like the basics of it in about 30 minutes and learn the majority, pretty much all of the language in about an hour. A lot of people literally just read the specification for the language to learn scheme because the language is so simple and short that you can learn it pretty quickly in a few settings. In addition, the language is also very simple, but we'll get into that as we go. And one of the things that I wanted to highlight about just how easy it is the fact that since it is so simple, MIT themselves decided to implement it as the first language as an introductory to programming. They don't use it anymore. I believe they probably use Python or something like that. It's kind of a shame that MIT gave up on it, but I understand that Python is a much more popular programming language now. Now, the next thing I wanted to talk about was the simplicity of Lisp and Lisp implementation's syntax. Lisp itself is a very simple language. In fact, the concept behind it is that basically as you're writing it as code, you're actually writing an abstract syntax tree. Now, if you have any compiler or recursive descent parser experience, then you've probably got some idea of what I'm talking about. But if you don't, let's give you a few examples. So just to get started, let's take a look at this code right here. So this is some simple C code. It is just really printing the resulting value of this expression right here. Now, right away, when you look at this, if you have experience in a bunch of different languages, then you might be a bit concerned on how this is going to be evaluated. In a function, it's very clear that this will operate on all of this, but we have no idea how this plus and multiplication will be evaluated and how it will be applied. You see, we could assume that it will do it the mathematical order of operations, where it will do multiplication first and then finish off by adding that to 1. But it also could just operate left to right, which is what a lot of programming languages actually do. So right away, there's a tiny bit of mental overhead that you have to do. And this is what you're doing, any sort of expression that doesn't follow a simple function format. You have to do this mental overhead and you have to worry about this extra complexity, which often can lead to a programming error. Now, if we evaluate this, we are in good luck. It does do the operations as we would expect. It multiplies the 1 by 2 and then adds 1 to give us 3. Should we change this code? Probably. In fact, the better solution would be to put all of this in brackets to make the evaluation a bit more clear. Now, the actual result of how this is evaluated and how this is parsed can be seen here. This is the kind of a visual representation of what the abstract syntax tree would look like. So we have the printf that is operating on these arguments. It has this string right here, which we won't really worry about how that would technically be parsed. And then it goes through the mathematical formatting. So it goes through the 1, and it takes that and it goes, okay, well now I have to apply the plus to the 1 and then something else. And the something else is this expression right here. So it goes through, it sees, oh, there's this multiplication. And so then it applies the multiplication to each of these. All right, now this is pretty straightforward, especially when you look at this and go bottom up, you kind of see how everything's going to be evaluated and how it will all be applied. Now let's look at the Lisp implementation of this. So as we can see right here, we have the Lisp version. And so this kind of applies how an abstract syntax tree would be created. So if we look at this abstract syntax tree up here, we will see, okay, it goes printf and it applies it to 2 different things. We don't really need to do that because we don't need to use this in Lisp, so we just cut that out. And so it goes print and it applies that to the plus. Now the plus is operating on 2 things, as we can see here. The multiplication is operating on 2 things, as we can see here. And it is all surrounded in brackets just like that. So there is pretty much zero way that you could misinterpret this because we are literally looking at the abstract syntax tree of Lisp. It's very easy to wrap your head around how this will be parsed and how this will be evaluated. Now this is a really simple example, but another example would be something like an if statement, and a bunch of different expressions can lead to a lot of programming errors, especially in a larger code base where these things can kind of sneak through. So this lack of mental overhead that you get kind of adds to the simplicity of things. And while it may seem scary at first, when you realize that most editors allow you to indent your code in order to make it more readable, it's a lot more simple. So you can see, okay, well, print is being operated on what? It's being operated on this. And then this is addition of 1. And then the thing that is being multiplied by is caught here. So it's kind of similar to when you write Python, except you don't have to worry about white space issues, copy pasting being a pain in the butt, all of that sort of stuff. It's much more straightforward. And in fact, if you wanted to make it really readable, you could write it like that, but that's a little overkill, but it does leave a bit of free hand to the user to decide how they want to write it. So this is literally what the Lisp version would look like. Just removing that extra little step over here. Once again, we can just evaluate that and we'll see that it operates as we would expect. Now, next thing I wanted to talk about was the actual formatting of this. So this format of function and then the arguments following it, this is known as an S expression or SEXP, if you will. Now, the next topic is homoiconicity. Now, don't worry, this is a term that you will see people throw around all the time. It makes Lisp sound really scary, but it is actually very simple, and the context of how you would use it and what it would look like is pretty straightforward. So we'll go through this. The idea of how homoiconicity is applied and what it means is it basically means that you can use the same structure that you use to write code as data. Now, this might sound a bit scary, but don't worry, we'll go through this step by step. Now, the best example of this in Lisp is a list. In fact, a list in Lisp is actually a S expression. So you remember that format of 2 brackets and then a function and its arguments. That same thing can be used to create a list. And all you have to do is prefix it by a single quote. So here is a really quick example. So here is an S expression that is prefixed by a single quote. And this actually just evaluates to a list. So this is the evaluated format of it. Very simple. You can actually take advantage of this as you code because you can really easily create complex data structures that are really easy for people to read. Now, there's a bit more to this, but I won't go into it too much in this video because it is a bit much. But if you guys go ahead and learn Scheme or Common Lisp, then you guys will learn a bit more about the actual structure of this and how it all works. But the idea is that you can operate on a Lisp the same way that you would operate on a function, and you can take advantage of it very easily. Now, for a more complex example, here we will see that code from before. So here's all we had. For those of you guys that wanted the exact same format, this is kind of how it looked before. And now if we just prefix it with a single quote, we now have a list. We have a list of lists. So each of these guys in here is a list. And because of that, we can actually treat this code as data. So if we just evaluate that, you'll see right there that this is a 2-element list. The first element of the list is the symbol print, and then the next element is this other list. So pretty interesting. And the value of this is that you can basically kind of pass around code, choose when you want to evaluate it, and this can be really powerful. As you can see right here, this is a very simple example, but here we define a variable that actually contains a quoted S expression. So that's kind of how people would refer to it. That is both this collection of symbols in here, as well as the code. So here we are doing message, which you can kind of think of similar to printf in C, but for Lisp. And so we're saying, all right, one value goes here and then equals the other value. Now the first value would literally just be the code that we have right here. All right, it's just taking the raw data, and then here it is actually evaluating it. Now, if we go ahead and run that, you'll see that it gives us the expression equals and then the actual evaluated code, which can be pretty powerful, as you'd imagine. Now, our next point is pretty straightforward. Once you have learned one Lisp, learning the others is pretty straightforward. You learn the edge cases of the other Lisps, but very quickly you'll realize what can and can't be applied. Big example would be Scheme. Pretty much everything in Scheme can be applied to other Lisps, besides some of the edge cases, like it has a different way of handling true and false from Common Lisp. But you'll see that very quickly. If you learn one of the Lisps, it's very quick and easy to start learning the other ones. Now, macros, if you have any experience writing C code, then you probably know about macros. Macros are basically a way to write something kind of similar to a function that can take arguments and then can expand and create new code in line. So the features of this might sound a bit strange, but this allows you to write new structures for programming. Probably the most interesting example that I have off the top of my head would be something like a use package for Emacs Lisp. Emacs Lisp is another Lisp implementation, kind of similar to Common Lisp. Now, the cool thing about it is that there is a macro right here called use package. It looks just like a function, but it can actually do a lot more than that. And it allows you to write a somewhat more declarative, if you will, configuration for Emacs. So for example, here we're like setting some values. Bind right here simplifies the format of writing new key bindings. Init is stuff that like runs at the initial start of Emacs. And then we can actually see that this can actually be expanded. So this is very short, simple. We can fit it all on one screen. Now, if we actually look at how this is expanded, you'll see that it actually does a ton of different things. It does a lot of error checking and really simplify the amount of code that you're writing. Now, macros have both their pros and their cons. You don't want to use them too much in your own code base because it does make it harder for new people to start up, but they can be really useful for extending the languages. For example, macros have been used to add many of the important cool features that have come from Golang, such as channels, its use of Go routines. That has been implemented in Clojure via core.async, and has been implemented in Common Lisp as well, and probably other scheme implementations just as libraries. They didn't have to be implemented as language features. We didn't need a new version of the language to be released. They are literally just libraries, and as a result, you can really extend the language to meet whatever demands you need. Once again, a really interesting language to look at in this context is Racket. Racket is a language for writing whole new languages with a Lisp. Which is really interesting, but we won't go too far into that today in this video. Now this one's very straightforward. It's been around forever. Lisp implementations have been around since the 1950s, and the fact that people are still happily using them is a pretty good testament for the fact that it has stood the test of time and that it will still be around. So if you ever need it, it'll always be there. This cannot be said for all languages out there. Many of them have not been able to really maintain their use case. For example, like COBOL has a very niche use case and can be used very broadly versus Common Lisp and Scheme have had new features implemented to the language, even though they don't actually meet the spec. Just because the libraries can be so powerful, you don't really have to worry about this. And like I talked about before, macros and the ability to extend Lisp, like we talked about before, basically are the reason that Clojure was able to implement a lot of Go's features very quickly and very easily. So we won't go too far into that. That is a really powerful feature, and because of that, the language will always get better. And it will always have whatever feature that you have that comes to mind, you can always implement it in the language, which is not really the same for all languages. Now we have the REPL. The REPL is probably one of the biggest selling points, especially for Common Lisp, less so for Scheme, because Scheme is more interested in the simplicity of the language versus Common Lisp is very interested in being an interactive programming language. So probably the best example would be just to start up Sly, which is a Common Lisp REPL, and right away we can start evaluating code, so +1. We could even take advantage of it by doing things like evaluate code blocks very easily, no matter what setting we're in, just because of the fact that we don't really have to worry about the indentation with something like Python. With something like Ruby, it does have quite a powerful REPL, but it isn't quite as simple to get the same interface. For example, we're editing this Lisp code. This is just plain out editing it. What are we going to be able to do? Well, I don't know. Let's start writing stuff. We can do use, and we can ask for completion, and boom, right away we get actual code completion. We aren't even in a whole project. We don't have a language server running, but just because the REPL is very powerful and very well integrated into Emacs, you can take advantage of it very easily, as well as being able to evaluate code right on the spot. So for example, if we did +1, 2, 3, and then we just evaluate that, we'll see right down here in the editor, oh, this is what it evaluates to. And we can actually take advantage of the REPL, and maybe we could do something like, let's add a string, and I can evaluate that. And oh, we've gotten an error. Well, look at this. Now we can actually go ahead and tackle that error. So we could retry the evaluation. We could abort. In fact, this one's not very helpful, but let's do X, all right? And so X hasn't actually been set. We've never chosen what X will be. So let's evaluate. And we see that we can actually do stuff. So we could continue. So retry using X, use value. So we could do, I don't know, 99. Hit enter. And then we still have the issue of the string. So let's abort this. Let's go ahead and get rid of that string. All right, so there we go. So we've gotten rid of the string, and now we can go ahead and evaluate it. Now we don't have a value for X, like I said before, but we can actually just recover right away. So we could change the value of X to 99, hit enter, and boom, it is evaluated properly. So this allows you to have a much more interactive interface and be able to recover from errors without maybe crashing your code. And this can be done while it's running. So you don't need your entire code base to compile. You can change things as you go. Really good example is a video that I'll link down below where someone does this writing a video game where they can like change the look of the video game while it's running, which is something that you don't really see very often. Really powerful, really cool. Highly recommend using a REPL if you're interested in Lisps. They allow you to get documentation. They allow you to get code completion. They give you a whole debugger. It's amazing. It's amazing. Now, the next one I wanted to talk a bit about was the ability to tackle problems at both a low level and a high level. This is more so for Common Lisp, just because Common Lisp has a much more broad spec and covers a lot of this stuff. Common Lisp has a lot of really interesting features for operating on a low level, changing memory addresses right while you're writing, versus most languages don't really offer that. You can do things like operate with pointers if you wanted to. In fact, people have written entire operating systems in Lisp and it allows you to operate pretty much at any level that you would need. Since as you can see, it can look very similar to something like Python, but it can also, once again, operate very low level without having to do what most languages do, which is where they reach out to C, where you have to write a little C code to operate at this low level. Common Lisp allows you to basically just write it in Lisp and then operate on that and get the same sort of performance you'd expect from C without having to manage a whole nother code base of C code, hire C programmers, remember how to write C, remember how to handle like this foreign function interface. And while this is possible with Common Lisp, it's not really necessary. If you obviously wanted to operate with a C library, then obviously foreign function interfaces would be helpful, but you don't need to do that. Now, if this hasn't sold you on learning a Lisp this year in 2022, then let me know down in the comments what is stopping you. If it is the time commitment, like I said before, it's easy to learn. If it is the fact that there's no jobs, Clojure is becoming very popular, you'd be surprised how often you can use Common Lisp for things like scripting. It's really powerful, especially when you compare it to something like writing a shell script where you're stuck with just everything's a string. And while you can get some of the evaluate sort of functionality with something like that, you obviously will run into a lot more bugs. You don't have type checking, etc., etc., etc. And finally, I wanted to give a thank you to my supporters on GitHub sponsors. Specifically, I wanted to thank DFDX, Tall Guy Jenks, Palatinus, and Carr. Once again, if you guys want to support this channel, feel free to click down in the description on my GitHub sponsors. I really appreciate it, and it really keeps me motivated to keep making videos. I know I went a bit on a hiatus at the start of this new year. I wanted to research some topics for videos and get in touch with some people so I could get some really interesting programming interviews. So I hope that you guys appreciate it as those roll out. There'll be lots of new videos coming out very soon. I have a few recorded and one that I'm editing right now that hopefully I'll be able to get out either later on this week or this weekend. Once again, thanks you guys for watching the video. Be sure to comment down below if you have any questions or any interest that you'd like to talk about. Be sure to like this video, subscribe, and hit that bell icon so you guys will get notified of my next video. Once again, coming out very soon, so make sure that you guys keep your eyes peeled for it. Anyways, guys, thanks for watching, and I'll see you later.